All right, scientific notation review. So hopefully everybody feels pretty comfortable with scientific notation. You looked at it in Science 10 and Math 10, I think, a little bit, but it is a skill that we are going to use a lot of in this course, and we need to be pretty comfortable with it. So we'll start with converting large numbers into scientific notation. We will look at converting small numbers into scientific notation, and then we'll look at going the opposite direction. Again, this is just a review, so I'm not going to cover it too deeply unless we need to take that deep dive. Then I'm willing to do that. So the first example I have here is 58,700. We want to convert this into scientific notation, which always looks like this, like one place value in front of our decimal, and then a maximum of 2 after that, multiplied by 10 to the power of something. And so we use scientific notation. I know that looks like not anything, but I'll show you what I mean. We use scientific notation in science to write really, 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 really big numbers or really, 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 really small numbers in a nicer way. Because if you even look at your formula sheet or your data sheet, you'll see that we have things like the speed of light or the mass of the Earth that are really large numbers. And it's such a pain to write a lot of zeros before or after a number, especially if you have to use that number frequently. So converting large numbers into scientific notation. What we want to do is convert this 58,700 into 5.87 times 10 to the something. We don't know what that exponent's going to be. So what's happening is, just a little side note here, if you don't remember this, 58,700 is the same as 5.87 multiplied by 10,000. Right, if I multiply those together, then I'm going to get 58,700. We can go one step further and say 5.87 times, well, to get 10,000, we can say 10 times 10 times 10 times 10. So normally when we write powers of 10, we can say there are 4 zeros. So we're going to multiply 10 4 times. Right? That's what happens with any power of 10. And then we can write this in a nicer way or in a little more compact way to say 5.87 times 10 to the power of 4, because an exponent represents how many times that base is multiplying by itself. With me? Awesome. So in this case, we know that it's going to be 5.87 times 10 to the power of 4. And that is scientific notation, this form right here. There is a shortcut. We don't have to do this whole process over here every time. And it is looking at jumping the decimal place is the easiest way. I like to do it anyways, or I find the easiest way to do it. So initially, our decimal place is right here, behind the 0, right? If it's not shown, then it's usually at the end of the number. And we are trying to move it right here. So we rewrite that as 5.87 times 10 to the power of, and to determine what power that is or what exponent that is, we can count the number of decimal jumps. So we jumped 1, 2, 3, 4. We jumped 4 times to get there, and 58,700 is bigger than 5.87, so that exponent should be a positive value, positive 4. We can do the same thing with 380 million. So we'll do it a quick way this time. We know that we want to write this as 3.8 times 10 to the something. We don't know what the exponent's going to be, but here we can count our decimal places. So the decimal starts at the back there. We want to move it between the 3 and the 8 because we want it to be 3.8. So you can jump that 1, 2, 3, 4, 5, 6, 7, 8 times. So now that becomes 3.8 times 10 to the 8. When we are looking at really, really big numbers, we use positive exponents. So positive exponents for big numbers. We should maybe do large. Large is more large numbers. Does that make sense? We're feeling okay? Yay. Okay, let's look at converting small numbers into scientific notation. So here I have, my decimal place has disappeared, 0.000000058. That is an annoyingly small number if we had to write that several times in a lab report or use it in a mathematical calculation. So what we want to do is write this in scientific notation to make our lives a lot easier. So we know we want to write that as 5.8 times 10 to something. And now we just want to count our decimal places. So we want to move the decimal between the 5 and the 8. It is all the way over here on the left. So let's just count our jumps. 1, 2, 3, 4, 5, 6, 7, 8. So we've jumped 8 decimal places this time. But we have to be careful because the initial value from example number 3 is really, really, really small. It is smaller than 5.8. Therefore, the exponent should be a negative value. So it's 10 to the negative 8. I can get into the math of that a little bit more, but this is a review. So if this is a little bit confusing and you're not sure why we use negative for that and positive for the other one, call me over and we'll get into it a little bit deeper. So with example 4 here, we want to write this as 5.73, but we don't want to write the rest of them. All of these are going to be not very important in the grand scheme of things, right? They're not very significant. So we do write scientific notation as 2 place values past and no further. Normally, you'll see it a little bit different sometimes in practice problems and stuff like that, but generally we want to keep it restricted to 1 place value in front of the decimal and 2 place values after, and that's it. So multiplied by 10 to the power of, well, we're going to jump our decimal. We want to move it right here. So we'll jump at 1, 2, 3. And it's a very small number, so we will say 10 to the negative 3. Does that make sense? Am I moving too fast for handwritten notes? Okay. If ever that's the case, just stop me. I can slow down, give you a minute. Again, this handwritten notes is a bit of an experiment for me, so, and for you, so we'll figure that out. Okay, converting back. I'll just zoom in a little bit. Oh, yeah, this is me with technology. This is basically how all my videos go, so. Like, what happened? How did that happen? Why is it happening? 10 to the negative, let's do 4, maybe. So let's convert back. So we have example 1, example 2. I really want to zoom in a little bit so I don't write on the bottom there. So we have 6.48 times 10 to the 5. We know that's going to be a large number, or larger anyways than 6.48. So what I like to do is write 6.48. Maybe I put that a little bit too far off to the right. 6.48, and now move my decimal. I want to move it 5 times, and I want to move it in a direction that's going to make 6.48 larger. So that means to the right. So 5 times to the right, 1, 2, 3, 4, 5. It's going to go right there, and then we fill our empty egg carton with eggs. This is what I always think about when I take eggs out of the carton when I'm making eggs. Zeros in the little egg cartons. Yes? Yeah, if that's the way you want to do it, absolutely. You just have to be careful going the other way because it'll be less zeros because you got to jump that first place. But you're right, that is not a bad way to do it. And then because that's sometimes messy, I always write it again. You don't have to. This is your journey. But I write that as 648,000. And I just get rid of all my little scribbles. Right, I write it again so that I don't have to see them. 3 point, look at that 3, it's terrible. Hang on. That's a little better. 3.76 times 10 to the negative 4. So again, we're going to use the same strategy, 3.76. And then I want to jump my decimal 4 places, and I want to jump it in a direction that will make 3.76, or this number here, smaller than 3.76 because it's a negative exponent. So if I jump it to the right, it's getting bigger. That's not going to work. So I got to jump it to the left. 1, 2, 3, 4. Put my decimal place in there. Fill my egg carton, and just for good measure, put one in front of the decimal, the free egg. And we get 0.00376. That is a quick review of scientific notation. How are we feeling? Good.